Hello everyone, this is Mu Qing,
This is Xiaowen.
and we are electrical engineering master students from Columbia University.
This is an introduction of our heart rate monitor chip project of course PPG6350 instructed by Professor Peter Kingat.
This chip is used to monitor the heart rate from the fingertip. Now let me briefly introduce the project. This project is based on the principle of PPG technique, which is a non-invasive method of measuring the variation in the blood volume in tissues using a light source and a detector. Since the change in blood volume is synchronous to the heartbeat, this technique can be used to calculate the heart rate. An infrared LED is emitted into the tissue in the fingertip, and the LED detector is placed in the opposite side of the fingertip to measure the resultant light. The PPG signal has both AC and DC components. The AC component is synchronous with the heartbeat and can be used as a source of heart rate information. This AC component is superimposed onto a large DC component that relates to the tissues and to the average blood volume. The DC component must be removed to measure the AC waveform with a large signal-to-noise ratio. This is the system implementation of the heart rate monitor. Since the useful AC component is only a very small portion of the whole PPG signal, so a high-pass filter is used to filter out the DC component, and two stages of OTA with low-pass filter are designed to amplify the signal to appropriate voltage level, and a potentiometer is placed between the two stages of OTA. Since the signal cannot be larger than the supply voltage, so the potentiometer is used to adjust the voltage gain of the PPG signal, and a hysteresis comparator is placed in the end to generate the pulses which indicate the heart rate. The output pulses will feed into the Arduino to calculate the heart rate and display it on the LCD screen. The cutoff frequency of high-pass and low-pass filters are 0.5 Hz and 4 Hz, so the heart rate range we can measure is 30 beats per minute to 240 beats per minute.
This is the PCB and this is the infrared LED and this is the photo detector. The fingertip should be placed between them and this is the chip. There are peripheral circuit including the high-pass and low-pass filter. And this is the Arduino and LED display. Now we are testing the functionality of the chip. First of all, let's look at the PPG signal generated by the photo detector. We can see that there are a series of periodical pulse which are very small in amplitude. The signal is fed into the chip and it is filtered and then amplified by the first stage OTA. This is the output of the first stage OTA. You can see it is amplified by 30 times, and this is the output of the second stage OTA. Since the signal cannot be larger than the supply voltage, so after the potentiometer and the second stage OTA, it becomes a little bit larger, so that is easy for the comparator to detect. Finally, this is the signal output from the comparator, and it is synchronized with the heart rate. Here is the demo. We can put our fingertip between the LED and the photo detector. We can see the heart rate on the LCD display. The data will be refreshed every 10 seconds.
So we can
Thank you for watching. Thanks Columbia University and Professor Peter Kingat for providing us this opportunity. And also thanks Moses for fabricating the chip.
If you have any questions, please check our website and feel free to contact us.